laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, selamat petang. Petang ni cikgu nak belanja serangkap pantun iaitu bersinar cahaya di senja 6 petang, berlari-larian si anak dara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Okay, bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera semua. Salam Madani, salam ABC. Okay, saya Cikgu Rosemawati binti Zaini, bertugas di SMK Bandar Bintulu, Sarawak, dari Akademi Bersiaran dari channel Cikgu Peh KH. Okay, sebelum kita mulakan kelas kita pada petang ini, lebih molek kiranya kita mulakan majlis ilmu kita dengan bacaan Ummul Kitab Al-Fatihah. Bismillahirrahmanirrahim. Amin amin ya rabbal alamin. Alhamdulillah bersiaran kita sekali lagi dalam kelas tuition online Akademi Youtuber yang juga merupakan kerjasama Indidik Malaysia dan Kelab Guru Malaysia. Sebelum kita mulakan kelas kita, ingin saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan, gambar profil yang bersesuaian untuk tontonan umum. Sila fokus pada isi pembelajaran kita yang akan disampaikan oleh Cikgu Peh KH. InsyaAllah semoga kelas kita ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Ambil peluang ini, ikuti setiap kelas online percuma Panitia Fizik menengah atas yang akan bersiaran pada setiap minggu, setiap hari Ahad dan Jumaat pada jam 3.30 petang. Baiklah, saya perkenalkan guru-guru yang ada bersama kita pada siri ini. Okey, Cikgu Izyan. Okey, kita paparkan wajah Cikgu Izyan. Cikgu Izyan yang akan bertindak sebagai control host pada hari ini. Seterusnya, saya selaku moderator dan pemerhati pada hari ini. Dan ingin saya perkenalkan presentator kita iaitu Cikgu Peh KH yang kini bertugas di Kolej tingkatan 6 Tun Fatimah, Melaka. Okey, nanti beliau akan perkenalkan diri lebih detail lagi ya. Okey, juga diingatkan link sijil penyertaan. Okey, hari ini kita tidak ada link sijil untuk kelas hari ini. So, okey, tanpa melengahkan masa, mari kita ikuti kelas fizik hari ini yang akan disampaikan oleh Cikgu Peh KH. Dengan segala hormatnya dipersilakan.
Okay, selamat petang. Thank you kepada Cikgu Yani selaku moderator dan juga Cikgu Izyan yang selaku control host pada petang ini. So, ini merupakan kelas tuition percuma yang dianjurkan oleh Akademi Youtuber under program Indidik Malaysia dan Kesatuan Guru Malaysia. Di sini kita ada dua kelas yang seperti tadi moderator sudah beritahu bahawa kelas tingkatan 5 akan diadakan pada setiap Jumaat dan sekarang adalah pada masa 3.30 dan sudah sampai 1.2 rayaan raya. So minggu ini disampaikan oleh Cikgu Rosemawati. So siapa belum lagi sertai kelas tersebut bolehlah visit channel Cikgu Rosemawati. Dan hari ini kita akan adakan kelas tingkatan 4 iaitu pada setiap Ahad 3.30 petang. So ini merupakan panitia Fizik SPM Akademi Youtuber Malaysia. Hari ini kita ada Cikgu Izyan dan juga Cikgu Yani bersama saya. Terima kasih bersama saya pada petang ini. Okay, so saya Mr.Peh kini mengajar di College Tingkatan 6 Tun Fatimah Melaka. So the topic I'm going to discuss today will be subtopic of the chapter 1. So the chapter 1, the topic is measurement. The subtopic will be scientific investigation. So the scientific investigation, actually, you have already learned the basic at Form 1, Chapter 1. So later on, some of the topic I will be recall back with you together. So today's subtopic 1.2, we have about 3 learning standard. So this is learning standard 1, where you need to able interpret the graph and determine the relationship between two physical quantities. Okay, so from last chapter, so Cikgu Hasnitah already let you know what is the meanings by the physical quantities. So they will be the quantities that can be measured. So for example, we have the mass, we have the length, and others. Okay, so for the first interpretation of the graph of the different shapes. So total, actually, we have 5 different types of the graph. So this is the first one. So type of the graph, a straight line that passes through the origin. So the origin referring to the point where x and y is equal to 0. So from here, you can see very clear that the straight line is passed through the origin. Okay, so this is the first type of the shape you'll be seeing. Okay, so for this type of graph, so we know as y directly proportional to x. So in BM, y berkadar terus dengan x. So that means that if I say the question asks you, what is the relationship between these two quantities? So where is y and x here? So you're referring to the graph. If this is a straight line and passing through the origin, so the relationship answers will be direct proportional. Okay. And from here, you can measure, you can calculate, not measure, you can calculate, okay, the gradients of the graph. So the gradient of the graph, the formula will be, you learn in PT3 mathematics, the gradients of the straight line. So here you can see we have 2 coordinates, which is located on the straight line. Okay, so S1, Y1, and S2, Y2. So the gradients will be, with the formula you learned already, y2 minus y1 over s2 minus s1. You actually can use y1 minus y2 divide s1 minus s2 also. Okay, so this is the formula for the gradients, which you actually already learned in PT3 mathematics. And then here, this is the linear equation. Okay, so the linear equation for this type of graph will be y equal to mx. So this mathematics straight line equation you actually also learn at the mathematics PT3 already, where the formula is y equal to ms plus c. And just now we mentioned that the straight line is passing through the origin, where there is a 0, 0. So that means the c here will be equal to 0. So left ms plus c. So this is the equation for this side of the graph. Then for the second, this is also a straight line, okay, with the positive gradients. Okay, positive gradients will be like this now. Negative gradients will be like this. Okay, so this is a positive gradients, and now the straight line is not passing through origin. So that means we have the y-intercept. Okay, so this is the formula just now we explained already. Y equal to ms plus c. Now we have c, and the gradients is positive for this type of graph. The relationship you may give as y increases linearly to x when there is a straight line with positive gradients and the straight line is not passed through the origin. So you can give this statement. Okay, so the impian is berdampak secara linear. Again, the gradients is also using the same formula. So we choose 2 points on the line. Okay, so this is a coordinate numbers. Okay, so here we're using symbol. So the formula is actually using the same. Then here, as I mentioned just now, there is a y-intercept. Okay, we put C lah, where you learn in PH3 mathematics already. So the equation will be y equal to ms plus c. So the main difference will be here we have c for second type of graph. So for third type of graph, firstly you can see this is also a straight line, but the gradients now is negative. Or you can see just like I mentioned to you already. So when like this will be positive, then down like this will be negative. So here, this is a straight line also, and the gradient is negative. And here again, you can see the straight line is not passing through the origin. So for this type of graph, as I mentioned, firstly, there is a y-intercept here, and the gradient is negative for the third type of the graph. So for the relationship, you may give as y decreases linearly. Linear represents a straight line lah, okay, so you can see this is decreases because the gradient is negative. So y is decreases linearly to x, or in BM, y berkurang secara linear dengan x lah. So the gradients again, we're using the same formula, where the 2 points will be also located on the straight line here. Again here, we can see there is a intercept y-intercept. So the equation will be y equal to ms plus c. Just the difference here, the m will be negative lah. Okay. Okay, so the fourth type of graph will be, here will be curve, no more straight line. You can see very clear. And you can see the gradient is positive. Y is positive. So you guys say you learn mx already. So for this point, you will draw a triangle like this. Here also, a triangle like this. Okay, so from here, you can see again, the gradient is actually this line. This line. So as I mentioned just now, when up like this is a positive gradient. So this one will be positive lah. Okay, so just the difference between these two graphs is here you can see this is a slow down. If I say this is a next chapter, you can see this graph lah, or motion at chapter next chapter. Okay, but here we just want to discuss the gradient is positive lah. So this is a positive curve and pass through origin. These two also the same. So for this type of graph, the relationship you may state as y increases with x, no more linear, because linear, as I mentioned just now, represent as a straight line. Here, curve, you just mentioned, increases. So in BM is y bertambah dengan x. Okay, then fifth type of graph. Okay, so here, if I say, as I mentioned just now, we draw a triangle at this point. So you can see will be down, right? So here we down. So this will be negative gradients and not pass through origin. So this one will be decreases. So y decreases with x. Again, when this is a curved line, so we no need to mention linear. Okay, so this is fifth. Actually, got another one. Okay, this is a curve with the negative gradients that not cut both exist. So you can see this is a graph. No any line will be cut the axis y or x here. Okay, so this one you can see at chapter 4. Okay, so we have two rules. Will be, you can see this type of relationship between y and x. So will be Charles law and Brazier law. Okay. Okay, so or another graph represent the relationship. You can change this type of graph to another way. So where the y still remain the same, the x will be changed to 1 over x. Okay, so if you change y against 1 over x, and you'll be get a straight line. So that means that the y and x, the relationship will be inversely proportional. Okay, so y berkata songsang dengan x. So if I say the question asks you what's the relationship between y and 1 over x. So you can see if y against 1 over x, they will be directly proportional. But if let's say the question asking you relationship between y and x, so will be inversely proportional. Okay. Okay, so we are finished the first learning standard 1. So we go to the second learning standard. So which is analyze graph to summarize and investigation. Okay, so analyzing graph to summarize and investigation. Okay, so here there are 5 important aspects in analyzing the graph. So the first, you need to know the relationship between 2 variables. So the variable referring to MV, manipulated variable, and RV, where just how we mentioned already. So from the graph, we have 2 physical quantity, y and x. Normally, y will be RV, x will be MV. So the relationship you may refer to learning standard 1. For example, just now I mentioned to you, where y against x, there is a straight line passing through origin. So the relationship between x and y will be directly proportional. If I say we get the graph will be y against x will be like this, the 6 type. So this one will be s and y, the relationship will be inversely proportional to each other. So that means the first one, you just observe the shape of the graph. Okay, so the method, interpret the shape of the graph. So just now I already discussed with you and the learning standard 1. Okay, so for example, just now I mentioned to you already. Okay, so this is a straight line passing through origin, so the relationship will be directly proportional. Second, this one will be inversely proportional. Okay, so this is the first analyzing through the shape of the graph. And the second, determine the physical quantities that represents the gradients of the graph. Okay, so we have the physical quantity x and y. So y is the physical quantity represented as m here, m gradients lah. Okay, so how we can know what is the physical quantity represented for the gradients? Okay, so here, firstly, we can calculate by using the formula we already explained just now, okay, by using 2 points, okay? And here we have the example to let you know, so what is the, actually the quantity physics, okay, physical quantity represented by the gradients here. So for x, here will be t squared, okay, oscillation period square. So this is a compulsory experiment for chapter 1, Form 4 syllabus. Later on, we will discuss this experiment now. And then the x will be mass. Okay. Okay, so this is the step to determine the gradients of the graph. So firstly, for calculate the gradients, firstly, you need to have a big enough triangle. So the triangle, you can see this is a dashed line here. Okay, so we need to choose a suitable point. Normally, we prefer to choose the whole triangle, okay, and just make the right angle like this. So we're using this point and this point. Okay, but this example, I just take from the books. Okay, so the point will be this point and this point. Okay, so make sure the triangle you draw must be at least x cm times x cm. So x cm, that means this is 1 unit. So 1 unit, if you measure by using the ruler, will be equal to 2 cm. So that means you need to have at least here to here, your triangle. Okay, 4 unit times 4 unit also can. Same meanings as SCM times XCM. And then the second, using the formula just now I mentioned to you already. So when we draw the triangle, so you will get the point. Example here, the point will be here. So this will be 90 and 2.5. Then another point will be here, will be x will be 10, and here will be 0.25. Okay, so you substitute to this formula, okay, and then you must give the correct unit. So how we can get the unit here? So here from the formula, the y will be with the unit of s squared. Okay, s squared divide the unit for gram here. So the unit will be s squared per gram. Okay, so the answer will be like this lah. So firstly, as I mentioned just now, the y1 here we're using 2.5 minus 0.25. Divide x will be 90 minus 10. So we get the magnitude 0.028. And the unit, I already give you the idea how to get the answer for unit already. So be second square per gram. So your answer must be together with correct unit. Okay, so this is the way we get the gradients and identify the physical quantity of the gradient. So the physical quantity of the gradients will be this lah. Okay. Okay, then the third analyze will be regarding the area under the graph. Okay, but not all the graph, the area under the graph for meanings lah. Okay, next chapter you will see three types of the graph where there is a displacement against the time. So maybe like this on the graph. Then we have the velocity against the time. Another one will be acceleration against the time. Okay, so for these three types of the graph, for s against t will be have the meanings for gradients. No meaning for the area under the graph. So normally we not find anything for the graph of s against t. Okay, then for the v against t, the gradient is actually represent as the acceleration. Okay, because the y will be v, x will be time. So this is the formula you actually learned also previously. And then the graph, area under the graph will be v times t. So it's actually represent as a displacement. So because we know that the velocity formula will be displacement against time, over time. So s displacement will be equal to v times t. Okay, so we get the unit for the area under the graph by multiplying the physical quantities unit lah. Okay, just now we divide, so this will be multiplied. Okay, so let us see the detail. Okay, so firstly, calculate the area under the graph using the relevant formula. So what it means by relevant formula? So from here you can see, here we have the triangle. So the formula for triangle will be 1/2 times base times height. So the base will be here lah. Height will be here. Okay, another one here is a rectangle. So will be here times here. Length times width lah. Or actually you can also using trapezium to calculate whole area here. So where here will be A, here will be B, here will be height. So the formula for trapezium for whole area here will be 1/2 A plus B times height. So this one is depends on your formula you want to use lah. You can combine triangle plus rectangle, or straight away you can using trapezium for this area under the graph here. Okay, then the B unit for the area will be product of both axes. Just now I mentioned to you already. Okay, so the unit for area under the graph will be unit y times unit x. So here we have an example. Okay, so this is an experiment regarding the extension of the spring against the weight of the load. Okay, so this is activity 1.3 you are going to see at your textbook. Okay, but actually this is the compulsory experiment at the Form 5, Chapter 1, Section 1.4. Okay, so here I just want to explain to you the area of the graph will be this area. Okay, so you can see this is a trapezium. Okay, so with the A, 1.3, and then the B 8.0, and the height will be here 0.5. So end out you get 2.33 for the magnitude, and then the unit, as I mentioned, we just multiply the y-axis to x-axis. So the y-axis will be cm, and then the x-axis, the unit will be Newton. So you can see it will be this. Okay, so what is the meanings actually represented by this Newton cm? Okay, so here the physical quantity for the area is actually work done. And work done, the formula is force times distance. You also already learned in PT3 actually, from 3. Okay, this formula. So here I just want to show you that the physical quantities of the area here for the experiment, extensions of the spring against the weight will be work. And then actually here, the gradients represent the spring constant. So what is the spring constant? So the spring constant is actually the stiffness of the spring, strength of the spring. Okay? Okay, so the unit, just now I mentioned to you already. So we product of the x cm together with y here. So we get Newton cm. Okay, so the fourth, the interpolation to determine the value of physical quantity. So what is the interpolation? Actually, this one also learned at your PE3 mathematics already lah. Okay, so if the value x is given, determine the value of y using interpolation and vice versa. So here I give you the example from textbook. Okay, so here we have first, okay, if you want to find the value of given here is x 1.5. So what is the value for y here? So the interpolation, that means we just draw the line at the existing graph is already given here lah. So from here you just touch the line here, you get here is 39 lah. So this is how we do the interpolation. Okay, so the method here is known as the interpolation. Another will be the question given you the value of y, 25 here. So from here again, you interpolate this line and touch the line of the graph here, curve line here. So you will see your x is here. So I just do some estimation. Here will be 2.4 lah. Okay, now so this is a method we know as interpolation. Okay, and then the last one here will be the extrapolation. So what is the extrapolation? Okay, so here you can see to determine the value x or y, but initially you can see here there is a straight line here, and after that we add on the line here represented as a dashed line here, okay, and here right as the extrapolation line. So why we do like this? Because actually you will see this side of the graph at chapter 4. Chapter 4 also hits, this is a 2 row you are going to learn, which is the Charles law and the pressure law. Okay, so for Charles law and pressure law, example V against T, temperature. Okay, temperature. Here is the volume okay, volume. So we just put any unit here example. Okay, so in the experiment, we are able to do maybe room temperature 25, and maximum we can get 100. Okay, but we cannot get any value after too low at our laboratory here. Okay, so for example, we get this line or for example, we do already experiment, maybe like this on the graph. Okay, so we want to find what is the value when the V is equal to 0. So be here, but we're not able to conduct the experiment. So to get this value, you need to add on the line, extend the line. Okay, for example, this so it's quite similar to this example Okay, so then you get the value value of the temperature when the V is equal to 0 already. Okay, so this method we know as extrapolation. Okay, so after the extrapolation, you may get any value where you are not able to get or conduct in the school laboratory. So for example, here, the question asks for the value where y is equal to 0 here. So what is the value for x? Okay, so here will be this 5.1. Okay, and then the second value you may get also at the area where the experiment not able to conduct. Okay, so example here, what's the value for y when the x is equal to 3.2? Negative 3.2 will be here. So touch again the line, you already extrapolate, then go to here, answer is 1. Then the last here will be example for y equal to 3 here, and then what is the value for x? So we get 1. You can see the value all we want to find out is out of the condition where we not able to conduct at school. Okay, so this is a method for extrapolation. Okay, so here this is an activity from your textbook, page 13. Okay, so the practice is actually want to let you know how to do the analyzing of the graph. So the aim here is to plot and analyze the graph using set of the given data. As I mentioned to you, this is the experiment you are going to learn next year, 1.4. And here you just want to know how to get the graph from a data given here. Okay, so here the table 1.5 is given already. So where there is how many value here? Okay, we have 8 data here. Okay, so normally for paper 3, we just need 5 data only, but here we just learn how to plot the graph. Okay, so how we plot the graph here? So firstly, you need to know there is actually 7 things you need to know. So what is the 7 thing? Later on, I'll let you know. So before we go to the further, so let us see the instruction first. Firstly, here is work in group. Okay, at your school, your teacher maybe will ask you to form a group. But here I want to discuss is how we plot the graph f against x. Okay, so f against x, so that means that the f will be at y-axis. Then the x value will be at the x-axis. Okay, so to plot the graph, so firstly, you need to give the quantitative physics for each axis x and y. Okay, so that means you need to identify what is the variable for this experiment. So for here is very straightforward. So it will be force and the extension of the spring. So the force will be here will be actually mv. Then the extension you are going to measure will be lv. Okay, so will be reverse what I just now mentioned. Normally the lv will be at y, mv will be at x but here this is there is a different meanings. Next year we will know. Okay, if you plot f against x and x against y against f so the gradients represent the different meanings. So from here, as I mentioned, the gradients will be f over x equal to the gradients. So we have the formula f equal to kx. So the gradients for graph f against x actually represent the spring constant, so the stiffness of the spring. Then if you plot the x against f, so the gradients is actually represent 1 over k, which is 1 over spring constant. So they'll be bring out the different meanings. But here I just want to let you know how to plot the graph. So this is the exception where the RV is at the x, y will be mv for this practice. Okay, so second, you have to give the units for both axes. Then third, you need to give a uniform scale. So what is a uniform scale? So normally uniform scale will be like 1 unit represent as the 1. 1 to 2. Later on, I show you what is the meanings of this uniform scale. Okay, and then the next will be you need to plot all the point correctly. And then another one will be baseline. So what is the baseline? Later on, I'll let you know. And then the last one will be the size of the graph. So here, there's 7 things you need to fulfill so that you can get the full marks for your paper 3. For the parts where you need to plot the graph. Okay, so this is the question asked you to plot the graph f against x. As I mentioned to you, so when the question gives you f against x, so that means the f will be drawn at the y-axis, and then the x will be at the x-axis. Okay, so first we need to identify the variable here. So I already boxed with blue color here, where there is the force and the extension. Okay, so here normally we not write force, extension, or spring. We just use the unit. We just use a symbol. So we can use F as a symbol for force, X as the symbol for extension or spring. Okay. Then second, you have to give the unit. So here already give you the unit for force will be Newton, and then the X will be cm. So you just label. You can see this is the first you need to give where this is a symbol and the unit. Okay, so first is a symbol, second will be the unit. Okay, then the third, uniform scale. Okay, so what is a uniform scale? Okay, so here to draw the scale, here, firstly you have to identify the minimum and maximum value. Okay, so here the minimum value for x will be 0.8, maximum will be 6.4. Your graph must be covered 6.4. Okay, and then for the y-axis, minimum 0.5, maximum is 4.0 here. Then what I mentioned, the uniform scale will be like this lah. Okay, so normally we start with 0 lah. For physics, it will be start with 0 lah. Okay, chemistry will be different story actually. Okay, because currently I'm teaching chemistry, so their graph is actually not need to for STPM lah. Okay, not need to start from 0. Okay, so for physics, SPM, we will start from 0 lah. Okay, so here, this is a 1 unit I mentioned. So the 1 unit here will be to 1 multiples here lah. So that means here will be 1, 2, 3, 4 like this lah. The second will be 1 unit here represent 2. Here will be 2, 4, 6, 8 lah. Then we can use 5. For example, here are 5, 10, 15, and so on. Another one will be 10. So 10 is actually, you can refer as a 1 also, because if here we put 1, 2, 3, 4, you just add 1, 0 will be 10. So we not use the 1 unit to 4. Okay, 1 unit to 3, 1 unit to 6. Okay, this is not correct or ununiform scale. Okay, so we use 1, 3, 5, 1, 2, 5 are easier. Okay, and then the next, okay, so here for this, okay, for this experiment, 0.5, sorry, x will be x exists, so 0.8 and 6.4, you can see is my scale here is covering 6.4 already. So here is more than 6.4, is 7. Okay, then the next here will be for force. So 0.5 to 4 is here. So also is covered in the scale here label already. Okay, and then, so from here you can see the one small box here. Small box here. So it's actually represent what's the value here. So here it will be 10 box lah. So for y-axis will be 1 divided 10. So the one smaller box here will be equal to 0.1. Then for the y-axis here will be 0.5 divided 10. So one small box here will be 0.05. So here 0.05 lah, one small box. And then the smallest division for the x-axis I mentioned just now already, 0.1. Okay, so this is we settle for the third item we need to fulfill for drawing the graph. Okay, then next will be plotting the point. So our first point will be 0.5 and 0.8. So here 0.8 S and 0.5 will be here. So it's about here. Okay, so you can use 0.8 divide the smallest division. So it'll be 8. So the box will be number 8 lah. Okay, then 0.5 divide 0.05, you get 10. So it'll be here lah, 10's box lah. So it'll be at this point. Then the second will be 1.6. So 1.6 you divide 0.1, will be 16, will be here. And then here is easy lah, 1. So it'll be almost here. Okay, and also others lah. You need to plot one by one. Okay, so this is tick number 4 and number 5. And then the next, okay, so here, tick 4 and 5, you must correct. So you can get 2 tick. Okay, and then the next will be the baseline. So what is the baseline? So to fulfill the baseline, firstly, numbers of the point different above and the below must be 0 or 1. So what is the meanings of this? And the point distance from the line must be less than 0.5 cm. So what is this? Okay, so for example, here, I show my line here. Okay, so this is a line I draw. Okay, so from here you can see there is a line here and there is a point. This is we know as the point below the line. And we have some of the line is actually, some of the point is above the line. So this is above the line. Some is exactly at the point. Okay, so for my case, you can see there is 2 point below the line. And here we have another 2 points above the line. So when we minus these two sides, we get 0 or less than 1. So that means this is fulfill the baseline. Secondly, the point must be close to the line. For example, here. So if I say the distance here is more than 0.5, although you meet where the above point and minimum and the bottom point less than 1, but when the point you get is very far, like this very far, so it also actually not fulfill the baseline. Okay, so that means your experiment actually you need to reconduct and get the suitable value Okay. Okay, so then the last one, your graph must be bigger than 4 times 5. So 4 unit will be 8 cm. 5 unit will be 10 cm. So that means your size of the graph must be actually half lah. So it'll be 4 unit and 5 lah. So this is a smaller size you need to meet lah. Okay, so the bigger the size you do, the more accurate for your reading lah. For example, you want to find the gradients or others lah. Okay, so this is the method how we draw the graph correctly. Okay, and then we continue for the activity 1.3. So we settle item number 2. So the graph I plot already. And as I mentioned, we need to fulfill what just now I mentioned to you. Okay, so let's say the graph 4 marks. So you get 7 tick, you will get 4 marks. Let's say you less 1 point, and one of the tick maybe 6. That means will be deduct maybe 1 mark lah. Okay, depends on the distribution mark for the exam question. Okay, so now we go to number 3. So what is the relationship between f and x? So you can see this is a straight line passing through origin. So this is what we learned in standard 1 already. Learning standard 1. Okay, so this is directly proportional. Okay, so f is directly proportional to x. Bn y f berkata langsung dengan x lah. Okay, then the b, the question asks you to calculate the gradients of k. Show on the graph how you determine the value of k. So the k here is actually the gradients lah. And actually, this is what I mentioned to you. This is the value of the spring constant. So the bigger the value, so the stronger the spring. Okay, but I'm not going to discuss about the theory. Okay, so we just need to know how to calculate gradients. So firstly, you need to draw triangle. Okay, so you must have this line and put right angle here. This is the first step. Okay, as I mentioned just now, the size of the triangle must be bigger than xcm times xcm. Okay, normally we get the end line here also can. Okay, and second, we need to identify the point. So this is a point 6, 3.8 for my graph lah. Okay, and then here is 0, 0. So I get 2 points already. Then we're using the formula lah. Y1 minus Y2, 0. S1 minus S2. And you can put unit here. You say you're not sure the value. So for the Y will be Newton. Then the X will be cm. So Newton per cm will be, can write as this lah. So let your answer with minimum 2 decimal places lah. Okay, then the second for C to ask you to change the value of the gradients here to SI unit. So here 0.63 Newton per cm will be like this lah. Okay. 0.63 Newton per 1 cm. So cm change to meter, we need to divide 100. So we get 63 Newton per meter. Okay, then D, area under the graph represent the work done. Just now I mentioned to you already lah. So the area of this area, the unit will be Newton multiplied meter, which is equal to joule lah. Okay, so you just get your value of Y, 3.8, and then here X, you need to change to 0.06 lah. If you guys say you want to get joule. Okay, so this is okay, from here I'm using another, okay, I understand already. Here why I use this 5 Okay, the question here actually is work need to scratch the spring by 5 cm, so must select here 5. The question asks how much of work you need to use so that your spring can ascend to 5 cm. So must be at 5, cannot use this point. This point will be 6. So it must be here. So I get the coordinate here will be 5.0 with 3.2. Okay. So that means the X 5 cm need to change to SI unit, meter. Then Y, Newton is already in SI unit. So I get 0.08 joule lah. Okay, then E, determine the value of F when X is equal to 3.5. Here I show you already. So 3.5 is here. So we interpolate. So we get the value here. E is 2.25 Newton. Okay, and then the F, predict the value of X when F is equal to 5.0 Newton. So you can see here, we have the data until maximum 4.0. So to get the value of 5, you need to do extrapolation, extra line here. So, and then our 5.0 will be here. So we draw the line here, reach this point and then go down. So this will be the extension of the spring when the force given is 5.0. So answer here will be 7.8 cm. This is the value for me. Okay, your answer should be around here. Okay, so this is the method how we do the analyzing the graph. Okay, so Cikgu Yani, kita boleh break sekejap.
Okay, kita akan bagi laluan kepada iklan. Okay, 5 minit. Okay, silakan.
Tuisyen online percuma. Tuisyen online percuma. Layari www.Akademi Youtuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi Youtuber.
Okey, kita teruskan lagi Mr. Peh.
Okay, so welcome back. Okay, thank you, Cikgu Yani. Okay, so we go to our last learning standard 3. Carry out the scientific investigation and write a complete report for simple pendulum experiment. So for simple pendulum experiment, you actually already conduct the experiment during Form 1. I think some of the students primary school also did this type of the experiment already. And so the scientific investigation method you should know already. And how to write a report, you also learn already at Form 1, Chapter 1. Okay, so here let us call back the scientific method. Okay, so scientific method is a systematic method used to solve scientific problem. So what's the step here? So first step will be identify the problem, making hypothesis, and then the third will be identify the control variable. Okay, so here the variable can be MV, manipulated, responding, and also control variable. And then we need to plan the experiment. Okay, so where you need to plan the procedure. So the procedure, how to plan the procedure. Actually, you need to also understand because your paper 3, there's a chance for you, okay, to face the type of question we know as tugasan tidak bantu. Okay, so where the experiment procedure is not provided, so you need to write the appropriate procedure for the experiment. Okay, and then you have to conduct your experiment, collecting data, analyze data, just how we learned already. Okay, so there is a 5 important aspect you need to know to analyze the data, and then you have to make the conclusion, then you do a report. Okay, so here you can see this is the example, okay, where you can get the situation at your textbook. Also, this is a situation where there is 2 kids here, where they are playing the swing, right? Okay, so with different length. Okay, so actually, what is the problem they want to try identify? So you can see here. Let us carry out the experiment. So before that, so you can see the Malay lady here. Friends, look over there. The 2 swings are swinging at different speed. So we expected from theory, so the shorter the length of the swing, so the speed will be the higher. Okay, so to identify this situation, okay, or to identify the problem here, we need to do the experiment. So where is the relationship between the period of oscillation together with the length? Okay, so we count this statement. This is a problem statement for this situation. So how the period of oscillation or the simple pendulum depends on the length. So this is how you write the problem statement. So you need to write your RV, which is represented as the period of oscillation here, and the length will be the MV. Okay. Okay, and then another one will be how we write a complete report. So here is a item you need to write in your experiment report. Firstly, inference, hypothesis, and variable. So we have 3 variables. Okay. So apparatus and material, procedure, result, analyzing data, and conclusion. This is the item you need to write in your report. Okay. So I using this textbook experiment, okay, so let you know all the items, okay, in your report . So the firstly, as I mentioned, there will be inference . Okay, so inference, this is a BM . This is English . Okay, so here the inference, as I mentioned to you just now the problem statement, we're using also the words depends. Before that, there is a responding variable. So here the responding variable will be period of the oscillation. And then the length will be the MV. So you just give the statement, the period of the oscillation of the simple pendulum depends on its length. This is a inference given in the textbook. So let's say the question asks you in paper 3, this is where, how you write the inference. Okay, and then the hypothesis here, we know already lah, or see we learned in Form 1 already. So the longer the length of the pendulum, the longer the period of oscillation. Okay, so this is the way you write hypothesis. The M, to investigate the relationship between, here will be MV, and here will be your RV. Okay, so the variable here we have 3. The manipulated variable will be length of the pendulum. Responding variable will be period of oscillation, and the constant variable here, the mass of the board must be the same. Okay, so apparatus given already here, so we the procedure will be like this lah. So for paper 3, normally you need to draw the apparatus arrangement lah here. Okay, and then you must label. So this will be normally will be first mark lah. Okay, then the next here. Okay, then the first sentence normally when after you draw the apparatus arrangement, you can give the statement like this lah. Set up the apparatus as shown in figure. Okay, and second, adjust the length of the pendulum to 20 cm. So you have to give your first manipulated variable. Okay, and then normally we'll come out together with first responding variable, what you need to measure. So here measure and record the time taken for 20 oscillation. Okay, one oscillation will be swing to here, back to here, and go to here. So back to original position will be the first lah. Let's say you swing to start from here lah. So we go to here and then back to here lah. Okay, this one we need to put to this side lah. So be like this lah. 1 to right and then back to left. So be first oscillation. So you need to count 20 lah. Okay, so this is your first RV. Okay, and then repeat step 4 and record T2. Okay, so for the first experiment, this experiment actually you need to get 2 reading lah, and then you get the average reading for your T average here. Okay, but paper 3 normally we just do one time. Okay, and then normally we not given like the table 1.6 here lah. Normally we straight away we have a value for time for 20 complete oscillation, but this practice we just follow lah. Okay, so why we want to have the two times of the measurement, because you want to reduce the random error. Okay, so then so follow this will be you need to get the average lah. Okay, and then normally here we need to have repeating data. We need to have at least 5 MV and RV, including the first one will be have 5. So here is more than 5, 20, 30, 40, 50, and 60. Okay, here is already 5 data we need lah. Okay, but we follow this, we can get another data. Total we have 6 MV and 6 RV here. Okay, and here you can look at the sentence number 3 will be the precaution. So sometimes the question in paper 3 will ask you what is the precaution for this experiment. So the text we skip already. So they place the pendulum bob at the angle less than 10 degree, 10 degree from the vertical. Okay, so when you give the answer for precaution, besides you showing the method, so here the method will be the angle of swing must be less than 10. So must together with the reason. Okay, so here is to ensure the pendulum bob oscillate in a straight line. Okay, because we know that when the angle you make is bigger, so the speed of the pendulum will be different. So that means the time reaction will be affected already. Okay, so that we will make the angle less than 10 degree as stated in the procedure step 3 here already. Okay, and then you have to complete the table here for your first experiment. Okay, so it will be like this lah. Okay, so for the table, okay, so here you need to have a 6 tick here. So what means like 6 tick? The first you need to give the symbol. Okay, you don't need to write length of the pendulum also. Never mind. But you have to give the symbol. L where represent as the length of the pendulum. Okay, and then second you have to give the correct unit for all physical quantities here. Okay, so here we have 4 lah. So small t represent as a time taken for 20 complete oscillation, and then t, capital T will be represent as 1. Okay, 1 complete swing lah, time second, and then you need to calculate t square also lah. Then the next. Okay, so for the reading, primary reading follows sensitivity of apparatus and consistence. Okay, so what is like this? So for the ruler, you can just see at your ruler. Okay, so the ruler, the sensitivity will be 1 mm, where it will be represent as 0.1 cm. Okay, so your reading of the length of the pendulum must be have 1 decimal place here. Okay, must follow the sensitivity of the apparatus, and then all must be have consistent 1 decimal place here. Then you can get tick 3 and 4. Okay, and then the next. Okay, this is the reading for length of pendulum. Then the next will be the reading for the time taken for 20 complete oscillation. So we're using the stopwatch. Okay, so here you can see the stopwatch. Okay, so the smallest division. So here we 5. This will be 6. Between 5 and 6, there is only 5 division. So that means 1 division for this stopwatch will be 0.2. Okay. So that means that your reading here must be 1 decimal place, and this is impossible for you to get 7. Okay, but if let's say you get your reading like this, here will be 5.2. Okay, sometimes students will get this type of reading at the middle. Okay, so it will be 2, 6. Okay, for this, I think we also still can accept 5.5. Okay, but normally we still encourage students to give round up to 5.6 or 5.4. Okay, but I think 5.5 is also accepted here. Okay, so make sure you get 1 decimal place here. Okay, so you will get the primary reading following the sensitivity of apparatus and the consistency. Okay, so this is the primary data. And then for the secondary data, here you can see 5 and 6. Okay, so 5 and 6 consistent decimal point for secondary reading. So you can give the decimal places up to 4, but normally 2 is enough because the graph paper is not able to draw so many decimal places. Okay, so here for the first average we get, for example, I show 33 plus 33.2 divided 2, so we get 33.1. So the others also using the same method. Then the T will be the time taken for 1 complete swing. So we're using data we get at T average divide 20. So this data divide 20. For example, I using 33.1 actually. Divide 20. This value divide 20. So I get 1.66. Okay, and others also the same. So how to get 0.88? Using 17.6 divide 20. So you get this value. So you can give 2 decimal places. Okay, and then T square, you can using, here I show you one value, 1.66 square. Okay, you get 2.76 and also others. Okay, so this is the method you do the tabulation. Okay. Okay, then the next here will be the question asked in your textbook or here. So firstly, plot a graph T against L and graph T squared against L on a separate sheets of the graph paper. So this is the first we want to do before we do for others. Okay. So first draw the graph T against L. Okay, so here this is the data what we get just now. You have to do your experiment and then you get this data. This is my data. Okay, so for first graph you will draw L against T. Second, you will draw T square against L. So that means for first you will draw T against L for this. And this you will draw T square against L like this two graph. Okay, so here I show you how to do the graph. Just now I show you the method already, 7 tick. Okay, so we apply here. So the first T against L, so we using these two row data. So 20 until 70, 0.88 until 1.66. Okay, so first you need to identify the physical quantity. So it will be L and T for the first graph. Okay, so you have to label at axis Y and X. This will be the first symbol. So we fulfill already this. Second, unit for axis CM together with second. Here, show already. Then third, you have to give the uniform scale. Okay, so here we need to identify our maximum and minimum. Minimum will be 0.88 until 1.66. Okay, and then the uniform scale will be 1 to 1, 1 to 2, 1 to 5. So my 0.2 considered as a 1 unit represent 2 So including the maximum value 1.66 here. 1.66 will be here. So until 1.8 And then here, okay, so here actually I did some mistake already. Okay, so here it cannot be started with 20. So must be 10, 20, 30. Here I have a mistake already. So here is not consistent. Okay, so here is wrong already. Okay, my graph suppose need to shift to behind. Okay, but here you just assume my one is consistent. But here is actually I did it wrong already. So suppose need to have 10, 20, 30. Okay, so let me do some correction first. Here suppose must be 10, 20, 30, 40, 50, 60. Okay, so here should be 70. Okay. Okay, so that means my graph here also wrong already Okay, so I try to do together here. Okay, so that means I need to switch my point. Okay, here. Okay, need to switch to here, only correct. Like this only correct. Okay. Okay, and then okay, so for the first point, how I get the okay, so until here already. Okay, so I get the scale here. One small box will be 0.02 Okay, here will be 10 divide 10 actually. Okay, so will be 1 actually here. Okay, so first point will be 0.88 together with 2.0. Okay. So 0.88 divided by 0.02. So I get about here lah. Yeah. So be here. So I need to switch a bit. Okay, so will be here. Okay. 0.88 will be here. 20 will be here. And then here, this point will be 1.11. And then together with 30, right? Okay, so after we plot this all, okay, so you have to draw. This one must be curved lah. So it'll be almost like this. Smooth line. Okay, so it'll be like this. Almost like this lah. Okay, so again, like just now I mentioned to you already. Okay, so our point here, maybe I need to tidy up the graph lah. Okay, so you have to make sure your point above and bottom cannot be more than 1. So for example, for this one, the upper part we have 3, lower we have 3. So 3 minus 3 is 0. So this line is also considered as the best line already. Okay, just the line is not smooth enough. Okay, so this is the way how we draw the graph for t against I. Okay, then for next will be t squared against L. So again, I have did the same mistake here now. So the graph is L against t squared. Okay, so firstly, identify the quantity physics will be L together with t squared. Unit will be this. So you have to label at these two as this. This one is correct. Okay, just a scale, same again. I did the same mistake here. Okay, I need to switch to another 1 unit lah. Okay, so we did together here. So here will be 10. Here will be 20. Here will be 30. 40. 50. 60. 70. Okay, so I need to correct the all answer already like this. Okay, so we shift to 1 unit. With this. Okay, so here, so you know already how to get the point, right? Okay, so you need to draw line, best line. So I get the best line through origin already lah. Very good answer. Okay, so here you can see easy I get the best line. So we observe together here. So here the above we have 1, 2. Here we meet exactly the same. Okay, so here 2 consider as the bottom, right? So above we have 2, bottom we have 2. So that means we get best line also lah. And you can see all the points very near to the line. So definitely it's less than 0.5. Okay, what I explained to you, what is the best line? Okay, so the problem here is I have a different data already lah. Okay, so let me show you next question. Okay, so the second, stack the shape of the graph and relationship. Okay, so here, okay, so these two graphs should be different already lah. Okay, so just now I brought the graph. For this is also almost the same now. So it will be pass through origin and then is a curve. So there will be t increases with I. So we can observe that the graph we get. Okay, will be like this, right? This is the answer we just prepare after this, correct? After this, so you can see this is a curve, and the line is past origin. So this is the T increases with L. Okay, so this is the answer for this graph. And then the next will be this. So you can see this is a straight line passing through origin. Okay, so this will be T square directly proportional to L. So the answer should be this lah, because after I mistake just now, here will be not uniform already. Okay, so in BM is 2 square berkadar langsung dengan L lah. Okay, so this is the answer for B lah. Okay, this graph is different from mine already. Just now I get one pass through here. Okay, so it will be increases linearly, but here is a mistake. So please follow the answer I just mentioned to you just now. Okay, I go to the next question. Okay, so next will be determine the gradients. Again, my gradients here will be wrong already because the graph already different. Okay, so I using the graph previous and try to get the correct answer together with you here. Okay, so the graph will be this. So I show you how to draw correctly lah. Okay, so now here, firstly, as I mentioned, first step should be draw triangle. So our triangle will be here. Okay, so I will choose this point. So here will be 70. 70 together with, you'll be here. The line will be here. So it will be 2.8. Okay, here will be 2.8. Okay, will be 2.8. Okay, so this is the first step. So the gradients will be, here will be another point, 0.0 and 0. So it will be y1 minus y2, 2.8 minus 0, 70 minus 0. So we get let me calculate on the spot. 2.8 divide 70. Okay, so here, this is better for you to change to meter. Okay, because we want to use the SI unit. So that means here will be 2.8 divide 0.07. So it's 0.07. 0.7. 2.8 divide 0.7. Okay, so we get 4. So the answer will be 4. Okay, and then unit. So for y will be s square. Then here will be meter. So our gradients will be 4 s square per meter. Okay, so answer will be 4. So later on we follow all the answer as 4 for me, for the gradients. Okay. Okay, so we settle the gradients. Okay, this is the method I show you, but this one is a wrong one already which is different with the answer just now after do the correction. So our answer will be 4 second square per meter. Okay. Okay, so the next will be given. Okay, so question given you the t square equal to 4 pi square L over g. Okay, where g is the Earth's gravitational acceleration. So the question is actually stated at your textbook already. So now we need to relate the gradients. The gradient we get is 4 s square per meter. I write here. Okay, so after the correction. So what is the value for g? So we need to calculate the g. Okay, so the answer, firstly, we know that our graph we get is from the t square against L. Okay, so this is the gradients we get. So it will be t square over L. Okay, and then the second here from the equation given, so we rearrange. So t square against L here will be the answer for our gradients already. Okay, so now we need to identify what is the value for g, so that we rearrange back. So we get our gradients will be equal to 4 pi square over g. So we rearrange, g will be 4 pi square over m. Okay, so here we need to do the correction here also lah. So our m will be 4. Okay, so the pi I'm using 3.14, and this value should be changed also lah. So we get 4. So what the value I get will be 3.14 times 3.14. So we get 9.86 meter per second square. So this is the answer after the correction. Yeah, after the correction. So we get the answer here will be 9.85. X6 for my reading lah. Okay, so here you can see. Okay, so my answer here is actually getting better. So the actual is 9.81. Okay, so it will be very close already. So that means the reading I get is actually slightly greater than 9.81. Normally, we will get the answer greater than the actual value. Okay, so why? Later on, discuss with you. Why we get the answer normally will be slightly higher than the actual. Okay, so our answer for my reading will be 9.86. Okay, so the next conclusion. So just now the hypothesis will be the longer the length of pendulum, the longer the time taken for the time period of the oscillation. So be this. We follow the hypothesis. The longer the length of the pendulum, the longer is period of oscillation. Okay, clear? So this is the answer for the discussion or experiment. Okay, so there is a further discussion in the textbook question. Okay, so the first question, why does the time for 20 complete oscillation need to be taken? Why we not just using one? Okay, because let's say one, the time is too short already. So very fast, the one oscillation too short already the time. So that the time reaction will be very easily to get affected. So that to get more accurate data, we need to have 20. Okay, so that the time reaction will be play a very small impact for your reading. Okay, so the answer will be to get more accurate reading. Okay, then the second, why is the measures of the time taken for 20 complete oscillations repeated? Okay, so that means we want to get 2 T1 and T2 right just now. Then we get average. So that means why you want to repeat your experiment at least 2 times 2 or 3 times. Okay, same reading, same meanings, same reason because we want to get more accurate reading. Okay, because when we do more experiment repeated, so the random error will be able to reduce. Okay, so here is the statement. Okay, so the random error is the error due to the observer. Okay, so the reaction time will be affected if we doing only one complete oscillation, and we doing the more repeated measurement, so we are able to reduce the random error due to the time reaction. Okay, so this is the discussion. Okay, then the next will be step 1, precaution that should be taken to increase the accuracy of result. Okay, so this one already stated in the procedure, step 3. Okay, we reduce the small oscillation angle, which is less than 10, so that the pendulum oscillate in a straight line. Okay, in another way, that means the time impact will be also able to reduce now. Okay, as I mentioned just now, if I say you make bigger angle, so the speed of the pendulum will be more compared to the smaller angle. This one speed will be reduced. Okay, so that means the time impact will be, or time reaction will be affected with the bigger angle of oscillations that are here. Okay, and then the next will be you can conducting your experiment at least 2 times. Okay, and get the average reading so that you can reduce the random error. Okay, so here we have 2 precautions for your reference. Okay, then the next will be compare the value of the G obtained from this experiment with the standard value of G. So the standard is 9.81. Just now we get is 9.86 meter per second square. So the difference will be very small lah. So we get is slightly higher. Okay, so you can see the value G obtained from the experiment is greater than the theoretical value. So this is because the air resistance slow down the acceleration, okay, and increases the oscillation time period. Okay. Okay, so therefore the air resistance will have an effect on the period of pendulum. Okay, so you will get slightly better than the theory due to the air resistance slow down the acceleration where the time of oscillation will be increased. Okay, so this is the explanation for your comparison data via the experiment and the theory. Okay, and then the last will be the two questions in your textbook. So page 16, formative practice 1.2. So the first graph play an important role in scientific investigation. So what is the use of the graph? Just like I mentioned to you already. Okay, so we have to try to relate the relationship between two physical quantities here, where y and x I mentioned to you in learning standard 1. Okay, and then explain the main step taken in the process of plotting the graph. I also show you already. We have 7 ticks, right, to get full marks for your graph. So firstly, you need to identify your variable. Here will be t square and l. Okay, determine the variable range. So will be their maximum and minimum value. Okay, so determine uniform scale. Okay, so here the even here actually is 1, 2, and 5 I want to mention to you. And then label physical quantities and units for both axes. Will be this and this. This will be symbol. This will be the units. Okay, and then the next will be determine the data plot and plot them on graph. So we need to get their value. Okay, and then this one in t square will be this. And then plot on the graph. Okay, then try to draw a best fit line. As I mentioned to you, the above point and the bottom point cannot be different more than 1. Okay, and then the distance of the point to your line cannot be more than 0.5 cm. Okay, so this is a method to draw the graph correctly. Okay, we go to our last question. Okay, so figure 1.13 shows the graph obtained from a study to investigate the relationship between the volume and the temperature. So this is the Charles' law, where you will going to learn in chapter 4, heat. Okay, so based on the graph given in 1.13, answer the following question. So what happened to V when data is increases? So you can see this is a direct proportional. If I say we see this part, right? So that means when the volume increases, so the temperature will be increases. Okay, so answer, very easy, straightforward. The value, oh, sorry, it's reverse. Now the question asks you the temperature. So actually it's the same also. Okay, so here when temperature increases, the volume increases. So V increases for answer A. Okay, then the B, determine the value of data temperature now when the volume is 0. So the volume of 0 is here. But we do not have any data for temperature. So as I mentioned to you, so negative about 200 is impossible to conduct in your school laboratory. Okay, even the very high standard lab also quite difficult. So that means we need to do extrapolation like this. Okay, so from here, okay, sorry. So from here, you can see the reading is at here, where is about 270 negative will be here. Okay, so the answer here will be negative 270 degrees Celsius. Then the last determine the value of V when the data is 300. So again, you can see we are not able to conduct, or we do not have the reading at 300 degrees Celsius. So that means, again, you do the extrapolation, you extend the line, okay, then you get 300 data will be equivalent to 22 cm cube. Okay, so it's a very simple practice where you can get the question in the textbook, or also you can get from my PDF. Okay, so that's all for my sharing today. So I pass back to Cikgu Yani, Cikgu Izyan.
Okey, terima kasih Cikgu Mr.Peh. Lama kita dah sampai pukul 5. Okey, tak apa. Terima kasih kepada semua anak-anak murid yang menonton di channel YouTube Mr.Peh. Okey, jadi Cikgu nak ucapkan Alhamdulillah lah selesai kelas kita pada petang ini. Tahniah kepada semua yang setia bersama kita pada petang ini dari awal hingga akhir. Jadi sebelum Cikgu tamatkan sesi secara langsung, mulalah klik butang subscribe dan aktifkan ikon loceng. Dan juga jika anda suka, bolehlah klik like dan share kepada rakan-rakan di media sosial kamu supaya kita dapat sebarkan ilmu dan juga beroleh kebaikan di atas perkongsian tersebut. Okey, tadi Cikgu Yani kata tak ada sijil. Okey, ada Cikgu akan sharekan di chat. Okey, pastikan anda login menggunakan email MyGuru, MOE atau e-didik dan Jawi sahaja. Okey. Okey, kemudian jadi sebelum Cikgu tamatkan kelas, Cikgu nak ucapkanlah mungkin ada anak murid yang tak dapat join kelas kita pada ini, boleh klik link-link di Akademi Youtuber apps ataupun di Jadual Jadual Akademi Youtuber untuk ulang kaji semula lah. Okey, ataupun boleh je tekan ke link di YouTube channel Mr.Peh, dan kalau hari Jumaat di YouTube channel Cikgu Rosemawati. Okey, jadi itu saja daripada hari ini. Cikgu nak ucapkan terima kasih kepada semua penyokong Akademi Youtuber. Doakan kami terus kuat bersemangat untuk membantu dalam membangunkan pendidikan Malaysia. Assalamualaikum. Bye.
Tuisyen online percuma. Tuisyen online percuma. Layari www.akademiyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi Youtuber.
Dibawakan kepada anda oleh